All right, so it is Tuesday, February 21st, and it is 7 o'clock, and we are ready to kick off week number 3. And so, as just sort of a brief reminder, if you take a look at the syllabus, and if you look at the email I sent out today, for week 3, we've got these 2 labs right here, which are, whoops, sorry. Mouse is jumping around there. So we're going to be working on lab 3311, software version control with Git. And I'm going to be talking about Git tonight and giving you some examples. And I'm also going to be talking about the Python classes review lab, which is 346. Now, this might not seem like a whole lot to do this week, but trust me, if you've looked at the labs, there's definitely quite a bit to do in these 2 labs. Now, for those of you who are really digging into the labs, if you run into any issues, if you were to take a look at the announcement that I dropped in here, I had a bunch of information in this email that got sent out today that is also in the announcement section. It talks about the 2 labs, and then I point out, and I'll pull this up in VS Code for you as well, but this is the final hands-on project that you're going to be doing by yourself. You're not going to be doing this in your teams. So this is something you would do on your own. So if you were to start taking a look at some of these things you need to do very quickly here over the next couple of weeks, you're going to have enough knowledge in order to complete pretty much all of this lab, I would say right up to step 10. And that'll probably be in the next 2 to 3 weeks. You should be able to complete the first 10 steps here that you're going to be asked to do for the final hands-on project. Now, back to the labs, I did up some video tutorials for you to supplement what the labs are covering. And again, they're broken down into the specific parts that follow along with the PDF in order to make them a little bit more manageable. And I walk through every step, give you an example of every step, demonstrate every step, explain what every step is and why you're doing it. And then I answer the questions that you would run into as well, right? So for this week, it's just these 2 labs here. But again, I say that's just it. But again, there's quite a bit that's going to go on in those labs, right? So hopefully everybody has had success in syncing up with their teams, because I want to call out a couple of activities, right? So for this week, we've got the 2 labs right here, and that would be, these are going to be due on Monday the 27th, right? So a week from yesterday. And then next week, you're going to be put into this project activity here, project activity number 2. Now, project activity number 2 for the teams doesn't require that you're producing any code or anything like that. In fact, if I was to download this and pull this document up, there we go. So you can see that it's going to ask you, well, actually, I'm sorry, this does ask you to kind of put together like a project that you would lead, and it's going to be in sort of an agile team format, which is different from what you just did. And so what I want to pull up here, and where I'm at, I'm bouncing everywhere. So 373, I think is what it said. So 373. So if you click on this, you can see that this is this project activity number 2, right? So I want to bring this to your attention because, again, this is not due this coming Monday. It's going to be due the following Monday, but I want to make sure that you guys have plenty of runway with which to work when you're doing this, because this is the first lab. Where are we at? So the deliverables are going to record the name of your Scrum leader. How did you select your leader? But where is it at down here? Yeah, okay, good. All right, so, and this is basically just asking you to follow along here. And again, only the Scrum leader would need to provide the PDF to be uploaded so that everybody gets their grade. And this is, again, it's kind of like a simple one that you're going to be working on, goes over the team communications, and you can see there's no code that needs to be provided. Now, the next project that you'll do as a team, and I want to make sure that you guys are aware of this so it doesn't sneak up on you. So again, that's 373, and that's not due until not this coming Monday, but the following Monday, right? Which I think puts us into, will actually be in March. I think it's March 6th is when that is actually going to be due. Now, this project activity here, right, which is project activity 3, this is going to require that you guys are actually creating code. And you've got 2 options on how you can move forward here. So we will be doing a MapQuest activity that's actually, I think it's this one right here, 492. So we'll be doing a MapQuest activity where you guys are actually going to be writing some Python code that's going to be pulling JSON data from MapQuest, and you're going to be pulling some directions out and things like that. So you'll have an option. Option 1 is you and your group can build on the activity in 492 and maybe provide some additional information of some kind, right? Now, if you decide to do that, that's great. If not, option number 2 is you could come up with totally new code. And you can see they give you the little scenario here that you're going to do some IPv4, IPv6 address application. Now, the overwhelming majority of students will go with option 1 because, again, there'll be a video that shows you step by step everything that you need to do to complete Lab 492. And 492 is you're using the MapQuest API, right? So you kind of already are familiar with that and you don't have to come up with something new. But again, those are the 2 options for 494. If we look at when 494 is due, and that's right, it hides it behind this. There we go. If you look at when 494 is due, it's not until the 20th of March. Now, I know that that seems like way, way, way down the road, but it's not. And it's going to come up quick, right? And the 492 lab that you do the week before with MapQuest is going to have a lot of information in it and a lot of coding that you're going to end up doing in Python, working with MapQuest. So make sure that you and your groups know that 373, again, it's kind of low-hanging fruit. You're just going to be filling the PDF out and you're going to turn that in. But then 494 is going to require you guys to actually be coding together, right? And that's where Git and GitHub are going to come into play. And again, we're going to see examples of that tonight. I'm going to show you like, oh, you know, if you were doing this as a team, here's how you might do it, okay? And the lab actually, 3311, shows you basically how to do that, right? So it's going to show you what you need to do. So any questions on the syllabus or what we've got coming up, especially around the project team activities? What questions do you guys have?
I just have a concern.
Mm-hmm.
You know, my team is super hard to get in touch with, and I kind of feel like I'm going to be on this on my own. So I did get, I had one team member that contacted me later in the week, but I'm a little concerned, I guess, because I feel like I'm going to be taking the work of 3 and doing it myself.
Okay, and let me see. Let me check something real quick here because I know I dropped it in right in here, not the activity. Where did I put the teams in here? Yeah, so you are with Eric and Gavin, and I do not see either of them in here this evening.
So I did not hear from Eric, but Gavin did reach out Monday afternoon, Monday evening, and gave his response to the last assignment. And he just said
Okay.
that he had already spoke to you that he cannot attend classes on Tuesday, but
Right.
I responded back to him, what's a better way to get in contact with you? But I haven't heard from him. So I'm just a little concerned, like, I don't know. So, I don't know what's coming up. I would have to look and see what the work's going to look like, but I'm a little concerned I'm not going to be able to collaborate, put it that way.
Yeah, so here's what we can do. Let me talk to you offline, and what we can do is we can move you into another group. So
Okay.
we would basically have still 3 groups, but we'd have basically a group of 2 and then a group of 3 and then a group of 4.
Okay.
So we
All
can do
righty.
something like that. That way, yeah, because I spoke with Gavin or exchanged emails with Gavin, and it doesn't sound like Tuesday through Friday is going to be good for him. And it sounds like he's only available on the weekends. And I know that that's usually time when you're not available. So I want to get you into a group that you'll be able to collaborate with, because you're going to get much more out of this if you guys are collaborating on things.
Okay. I appreciate it. Thank you.
Yeah, no worries. No worries. All right. Any other questions on the syllabus, right? So again, our focus this week is 3311 and 346. All right. If there's no questions, we're going to jump back over here. I can kill that. Let's do, oh, wait a minute. Which one is from tonight? Huh. Hold on a second. Well, that's odd because, oh, yeah, this is Fishing Frenzy. Okay, this has got to be the one here. All right, so here's the Book It code for tonight. So dive on in here. We're going to warm up with a Book It activity. We've got a different theme we're going to be playing with tonight called Fishing Frenzy, which is really cool. And so remember, you just go to https:// and you got to make sure you put the play in there, play.bookit.com. And then we're going to dive in to get. So go ahead and join in. Make sure you use your real name when you join in. Yeah, in fact, Christy, if you hang out tonight after we wrap up, we'll go ahead and get that sorted out and get you moved into a new group.
Professor?
Yes.
Professor, right now I'm driving. Cannot participate the quiz. So I need about 10 minutes, and then I'm gonna able to parking. So can I skip this quiz?
Oh, yeah.
quiz.
No, this isn't graded, so it's totally fine if you need to
Okay.
skip. Yeah, let me
Okay.
here, hold on one second. They're saying the code's not working. I wonder if the code's not working because it was like a stale session there. So here, let me get the right let's generate a new code. How about now? All right, how about this code? 7340897. 7340897. So this code should work. This is fresh. Just responded here, and I brought the other one up earlier. There we go. Okay, Nathan's in there, so we know it's working. Yeah, I brought the other one up earlier so we would have it teed up here ready to go, and it looks like it may have just aged out on me. All right, Ange is in here. We've got Nathan. We've got Ryan. We've got Dylan. Hopefully Dwayne's not having any technical issues this evening. All right, Dwayne is in there. So I think we're waiting on Michelle's and Christy. Yeah, we got Ryan, we got Nathan, we got.
All right. Give me a sec. I'm trying. Hold on one second.
No worries, no worries. Yeah, you go to https://play.bookit.com.
All right, mine says waiting in lobby.
Who is that?
That's Dwayne.
Oh no, Dwayne. I see you. You're in.
Okay.
Yeah, I see you. You're in there. All right, so we've got 6 out of 8, and we got Banshoon's on the road. So it looks like we're just missing 1, 2, 3, 4, 5, 6. So it looks like we're missing Michelle's. All right, well, we're going to get going here. If you didn't get a chance to pop in, you can still join in. The code will still be displayed, and I'm going to go ahead and kick it off here. So here we go. Click to cast your line. And there will be some questions that you guys should know the answers to from the previous week. We worked some of those in there. All right, and away we go. And if you get the megalodon, there's a megalodon apparently that weighs, I think it's like 10,000 pounds or something like that. And again, some of the questions, if you haven't done the reading for module 3, right, some of the questions you may not know the answers to, but that's okay. All right, Ryan is in the lead with 81 pounds. Christy in the lead with 271.
I don't really understand what I'm supposed to do. So,
Oh, yeah. So if you go to https ://, and actually here, let me put in the chat. I'm sorry, as I'm sitting here saying it, let me put it in the chat. So I'll put this in the chat for you. It's https://play.bookit.com. So if you go to that link I just put in the chat, and then you type in the
wait, I'm already in the game. I'm Ange.
Oh, you're Ange. I'm sorry. It's coming up as saying, oh, it doesn't say Ange for your name in the Zoom. That's why.
Oh
Okay.
yeah,
Okay. Gotcha. Sorry about that. And so did you
Yep.
have a question?
Yeah. I'm like looking at my phone right now, but there's nothing to do. It's saying look up at the old screen.
So I would try from a computer.
Oh, okay.
Yeah, give it a try from a computer. All right. Dwayne is catching up with Christy. Uh-oh, the jellyfish. All right, Christy back into the lead with 344 pounds of fish. Dylan into the lead with 434 pounds. Dylan, did you get a megalodon? Because you just jumped to third. Ryan, 4,700 pounds. All right, Anj, I see you in there again. Yeah, so go ahead and you should be able to run it now. All right, Ryan with 47.66, Dylan with 35.89, Christy with 377. And 3 minutes and 30 seconds to go. All right, Ryan up to 9,576 pounds. All right, Ange on the board. Well done, well done. All right, it's the attack of the frogs. All right, 2 minutes and 30 seconds to go. Ryan in the lead with 9,746, followed by Dylan, 5,303, followed by Nathan at 754. Dwayne up into third. All right, Dylan has just jumped into first place with 18,800 pounds. Minute and 45 seconds to go. All right, Ryan closing in on Dylan. A minute and 30 seconds to go. Uh-oh, frenzy. It is a frenzy. Dwayne moves into second with 18,300. Dylan is at 33,500 in first place. Ryan in third, 15,700, 45 seconds to go. And it's the blowfish attack. All right, we've got 30 seconds to go. Is anybody going to catch Dylan, who's got 39,900? Ryan in second, 28,600. Dwayne with 22,200. 15 seconds to go. It looks like Dylan may be taking this one. 10 seconds. All right. Final standings. Nathan in third, Ryan in second, and Dylan held on for the win in first. All right. Well done. So a lot of those questions that you saw are questions that you're going to run into in chapter, or I should say in module 3 of the course. All right. So let's back up here. So let me ask you this. What questions do you guys have over any of the material that we have covered up to this point in the course? So you have any Python questions that you're curious about? Just kind of open it up if anybody has any questions about anything. No, nobody has any questions about anything. Okay. All right. If there's no questions, then we'll go ahead and move on. Now, the first portion of Module 3 is a lot of reading about software development. And you've got the waterfall method, you've got the agile method, you've got the lean method, right? So it goes over those, you know, in the SDLC, which is the software development lifecycle, which you probably saw a question for in the Bookit activity. And it goes over that material. Now, that's all stuff that you can simply read. I want to focus in on when we get into the labs, right? So the first lab is, whoops, I'll pull it up here, is the Python. Oh, you know what? Did I not include that? Hold on one second. Did I not include that in 312? I'm pretty sure I included that, but that's not on the syllabus, is it? Okay, so lab 312, which is that first lab, I did the videos for it, but it's not something that we're going to cover because it's just about the virtual environment. So that just threw me there when I saw that. I was like, wait a second. So again, the software development, different methods and things like that, you can go ahead and read that. We want to focus in on the version control system because this is where the rubber kind of hits the road here in this module. And here's where the level of complexity kind of picks up for the course, right? Now it's going to talk about repositories, but we're really focused in on Git. So let's talk about Git. And we're going to do it right here from the CLI, right? So one of the things that you can do, right, with Git is it's a software version control system. Now, the old school way, and when I mean old school, I'm talking like 30 plus years ago, the old school way of doing version control is, so let's say I'm in this directory and I want to make a change to this lab file right here. So what I would do is I would say copy the lab, and then I would make a copy of it and call it the exact same thing. So lab 4.5.5 .get py, but I would say something like .orig, maybe put in today's date, and then maybe put in my initials, right? And so if someone came in here, they could look and see, oh, okay, well, Travis on Tuesday, February 21st, made a change to the original file, right? And so the file that's here now that I would have gone in and changed, this is the backup copy that I made, right? So that if like a week or two later, someone says, yeah, you know what, the script, it's not doing what you said it was going to do, and we're having problems with it. Can we just go back to the version that actually worked? And then what you would do is you would say, sure, we can do that. So I'll do copy lab 4.5.py.orig, and we would copy that back on top of the original lab, right? Or the current lab, which is that one right there. And so all I did here was make a backup of that file and named it that, made a copy of it, right? And then a week goes by, it's not doing what we think it was going to do. My changes are bogus. So then I basically come back and I say, okay, copy that original file that I knew was working before I got in there and changed it, and, you know, basically override it on top of the current file so that we get back to a good working version, right? So this was kind of like the old school way to do things. And then Git came along. Now, to be clear, Git is not GitHub, right? GitHub is its own little private company that's doing their own thing, and they've got a really cool, slick interface that you can work with. And Git is this command line utility that we're using here from the Linux command line. So, for example, if I was to go into the labs, devnet source, let's see what we've got in here. I thought I created a CTS. No, okay, so I'll do it right now. So I'm going to say make dir, and we're going to call it CTS-233, right? So if I cd into if I cd into CTS-233, and we'll clear the screen, you can see there's nothing in here, right? There's no hidden files with the exception of the dot and the dot. And remember, the dot represents the current working directory, which is the directory I'm currently in. And the dot is the parent directory. So it's the directory right above, immediately above the directory that I'm in here, which would be devnet-source, src. So if this is the directory that I wanted to do some development work in, I could basically say git init and hit enter. And you can see it says initialized empty Git repository in this directory. Well, what is the Git repository? Well, the Git repository is, the Git repository is nothing more than this .git hidden directory. So literally all I do is go into the directory where I want to start tracking my files, maybe your final project, right? Or the teamwork that you're going to be doing. And I'll give you an example of what that would look like with the team angle. So here, right, I'm like, okay, great. Well, I've got this Git directory, and then the lab is going to have you work on some global config stuff, right? So they're going to have you type in here, git config, and then -- global and user.name. Now, the username that you want to use is your GitHub username, right? So I would put in here Travis P. Bonfigli. And then we're just going to pull it back and we can do the email address. Now, this information is also going to be associated with the commits that you're making, right? And commit is when you make a change to a file, and you decide that you want to commit that change, that you're happy that that change works. And I'm going to show you some examples of that as well. So I would put in my email here. So we'll say, and actually I'll put in the Travis P. Bond. I should have left the Bonfili in there at gmail.com. So Travis P. BONFIG. All right. So you can do that. Now the lab shows you those two. In the video, I show you that there's other ones that you could do. You could do user initials if you wanted to. You could add that. And I'll just put in here, oops, TPB. And how do we see all this stuff? Well, we say git config -- list, right? And you can see here that I've got all of these configuration settings for this GitHub repository. Now, the thing about this GitHub repo, right, or this repository, is that it exists, and if I was to shut the virtual machine down or log off or go away for a week or log out, it's still here, right? It's in this directory. It's in the Linux file system. And Git knows that it is going to be tracking things because I ran that git init command. Now, if I go down to a different directory, I want to show you another way that you could do this. So let's say that you know the name of the directory, that I wanted it to be CTS-233, and here I'll just change the name a little bit. You don't have to do the make dir command and then say git init inside of that directory. You can literally say git init, give the name of the directory, and now if I just CTS in there, it created the directory for me. So it kind of does the make dir command for you. So there's two ways that you can initialize the repo. You can make the directory, cd into the directory, and type git init, or if you know the directory name that you're going to use, right, and you don't want to do the make dir command, you can just type this from the parent directory in which you're going to create your repo. And so here, again, I just did this in temp because I don't care if this one stays around. And that's a good note here, right? Anything you do in temp in /tmp, when you reboot your system, it's gone. So this is going to be gone. And again, I'm doing it in here because I don't care what happens with this because I'm not going to use this for a bunch of examples. But this is just to show you another way that you could do it. And there's that .git directory. Now, we're not overly concerned with what's inside that Git directory, but just know that this is where it's tracking the branches. The head, right? That points to the latest, most current commit, right? So it's pointing to that. You've got some objects it's tracking here, some info, you've got description, right? So this is your repo, basically. Okay, so let's get back to the one that we were in here in DevNet source, CTS-233. Let's clear the screen, ls-la. All right, so I've initialized Git. I've set some commands, right? And so what do we want to do here? Well, you could do what's called cloning, right? And the chapter will talk about cloning, where you can pull down somebody else's repo. So let's say that your group facilitator, right, or your Scrum leader creates the GitHub repo, right, in GitHub, and puts the template for the project that you guys are doing together, puts it out there. You guys could pull that information, you could pull that file down, and you could put it into your Git directory. Now, one of the key things to remember is if you're cloning something, right, it already comes with the .git directory. So you don't actually have to do the git init. It's as if it's already been done for you. And let me give you an example of that. So I'm going to cd back up here, and we don't have anything. I'm going to do a git. Actually, I'll just do a make directory, and we'll call it devnet. So I'm going to cd into, devnet. Now, you'll notice that devnet is not a GitHub repo. There is no .git file in this directory, right? So hopefully everybody sees that. So what I'm going to do, and I need to look over here because I can't remember the full path here. So here's how I can say git clone. So I'm going to go to somebody else's repo that the Scrum leader uploaded a copy of the project, whatever it is you guys are working on, and I'm going to pull that down, and this is going to do the equivalent of not only the get init, but I'm going to have everything I need. So I don't have to do the get init if I'm cloning from somebody else's repo. And watch how that works. So I would say https:// we'll say github.com/Cisco devnet/pyats coding-101.get. Now, I would highly recommend that you maybe make a note of this, because this is a real live repo that the Cisco DevNet certification book authors put out there, and it has some PyATS files, right? For PyATS is like unit test, and we'll be talking about unit test next week. So if I hit enter, take a look at what happens here. Cloning into PyATS coding 101. So there's 71 objects that are going to, it's all these files, bunch of code files. And you can see that we got everything. We didn't have any issues. So now when I type ls-la, I want you to watch what happened as a result of me cloning somebody else's repo. So now we have a new directory. And if I go into that directory, we see there is the .git directory. So it has already, in a sense, done the git init because, and we know this because of the following. If I clear the screen, if I say git status, it's telling me that I'm on branch master, right? Or I typically refer to it as main, right? So I'm on the main branch. Says it's up to date, nothing to commit, working tree clean. If I was to just maybe go into like, /temp and say git status, you can see we get an error, right? It says this isn't a Git repository. Because of what? The .git directory is not there. So if I cd back to my home directory and we go to labs, devnet, clear the screen, ls-la. Oops, sorry, I've got to get back into PyATS. So here, when I say git status, right, this is a Git repo right here. So what I'm saying is, the Scrum leader or whoever is the group facilitator who's going to kind of organize things, if they were to take the project file and then upload that, or do it in Git, and I'll show you an example of this, and upload this to their GitHub repo, all you would have to do is clone it. And then you now have a copy of the latest and greatest from the GitHub repo when you guys are working together, right? So that's how you clone. So now you know how to do git init 2 different ways to fire up a GitHub repo, and you know how to clone somebody else's stuff from their repo. In fact, let me go ahead and pull up, and this is probably a good spot to do this. And where's the GitHub at here? I thought I had, oh, here we go. Yeah, okay. So this is my GitHub, right? Travis P. Bonfili, and you can see the Dev ASC study team. And this would have been from, I did it 4 days ago, I was messing around. So I created a repo here, and there's the devasc.txt file. So the question becomes, okay, well, how do I figure out how to get this file? So remember, whoever your group leader is that puts this up here, you're going to know that it's github.com. You're going to know the name of their account, and then you would know the Dev ASC study team, right? Or like whatever you're going to call your team. And so that's the path that you would use down to the file that you're trying to get. Now, this is probably the most important part, and Ryan can relate to this because Ryan actually asked me a question about this earlier today. When you go to set up your GitHub repo from the command line, right, from the virtual machine, and in the lab, it's going to have you do that. And so let me go ahead and I'm going to duplicate that part here real quick. So hold on one second. Yeah, so in order to add your repo, you're going to say git remote add Now, right here, they show you the word origin. And pretty much like everything, you could put whatever you want, right? You could call it GitHub if you wanted to. So, but we're going to stick with origin. So get remote add, and origin is going to be an alias that you can use later that represents your whole GitHub path. And you'll see right here. So I'll say https://github.com/ the GitHub username, Travis P. Bonfili, / devasc, what do we got? --study -team.get. And so this is how on my virtual machine, I tell Git on my local system, my virtual machine, that, hey, I'm adding this remote repository to which, oh, okay, so it had already existed because I already added it. So to which I can then upload or pull things down or upload things to later on. Now, when you go to do this, and I want to make sure that when you go to push something to the repo, you're going to be asked for a username, right? Which is, mine would be Travis P. Bonfili, but more importantly, the password, right? So let's do an example of that. So do we have a file in here? Okay, so it's all these coding files. So I'm going to go ahead and let's jump back to, and I can't remember. Oh, get intro. There we go. Yeah. So let's go ahead and say, right? So here in this directory, you can see this is a GitHub repo because it has the .git directory in it. So if I was to do the following, right, and say git status, you can see that we've got this devasc study team is untracked, and that's fine. We're okay with that. So here's what I'm going to do. I'm going to VI that devasc text file. And I'm going to add this line in a whole bunch of times. So something really conspicuous. I'm going to save it. So I'm going to say git status again. And you can see here, it's telling you, hey, you modified that devasc text file because, again, it's tracking my changes because I've added this file in. So when I want to push this file, I'm going to say git push origin, right? Remember, origin represents what? My GitHub repo that I've created all the way down to the devasc team thing. And so I say origin, and I'm sorry, you know what we need to do before I do that? Let me do GitHub add devasc text, right? So now when I say git status, it'll be green because I've added it, right? When I was changing it, I changed it in what they call the working directory. When I add it with that command, GitHub or git add devasc.txt, the name of the file, it changes to green here. And the reason it changes it to green is because it's now been moved from the working directory to the staging area. And the staging area means I'm ready to do my commit. So I can say git commit -m, whoops, and I'll just put in here added bogus lines, right? And you can see that one file was changed. I had 14 insertions, right? So I inserted 14 times that line, and it only added to the index, right? That file because it was green. If I say git status, devasc study team never got added, right? It hasn't been moved from the working directory into the staging area. So it's just going to stay there red. All right. So now that that's been put in the staging area, let's go ahead and do the git push. And I've committed it, right? I did the commit. So now I'm going to push it up to the GitHub repo. So we say git push. Oops, sorry. And there we go. We say git push. And I use that little alias I created earlier when I said the git add remote. So I say git push origin, which represents my GitHub repository for the team. And then we're going to commit from the main branch, right? Which is where I did the commit. To see the branch that you're on, if I say git branch, you can see here, and again, I was using these for demo purposes, but you can see here, we are on the main branch. So I'm going to push from git push origin, main branch. Now watch what happens here. Wait a second, where'd I go? Origin does not appear to be, and it is and I do. So hold on one second here. All right, so we've got that, and that is there. So hold on one second here. Git push. Or did I misspell something there or not? Origin does not appear to be a Git repository, and it definitely is a Git repo. So let me do the git add remote again. Let me do the git add remote again. Or git remote add, sorry. So we'll say git remote add and origin https://hub.com/Travis B. Bonfili. And hopefully I didn't mess this up by doing a bunch of demo stuff. -team.get. Okay, so there we go. Well, that's interesting that it added it because I'd used this before, so now I'm confused as to why it didn't have that info in there. Okay, so irrespective of that, we sorted it out. I went ahead and did the git remote add, and I added in my GitHub repo. So now I'm pushing the dev.asc.txt file that I just committed on the main branch, and I'm going to upload that to GitHub. So you can see here, username for HTTPS. So the username is Travis P. Bonfili. Now, here comes the confusing part. You're going to see where it says password for Travis P. Bonfili at github.com. Now, here's the beauty of this. It's not a password that they're looking for. So as of August 2021, GitHub no longer supports the username password thing for this. You need what's called a personal access token. And so you're probably wondering, well, where does that, how do I get that? So it's actually pretty simple. So in your account in GitHub, you create your GitHub account. You're going to come here to the little icon with, if you have a picture uploaded or whatever, but you can come to your profile and you're going to come down to settings. And settings is going to bring you here. You're going to go all the way to the bottom, developer settings. And you're going to come down to personal access token and you're going to go to tokens classic. And you can see here, you can generate a personal access token, right? Generate new token. And we just want the classic token, and that's exactly what we're going to do. And I have two-factor authentication set up. So let me let this cycle. 4284. All right. I'll just call it Dev.asc study team. There we go. All right. So now you're going to generate this token, and you can pick the scope for the authentication that you want to provide, right? And so if you wanted to just go ahead and pick all these different things, and this is for the personal access tokens, and so I'll just pick everything here. User and delete the repo, right? Whatever. All right, so now that we have our personal access token, right? I click on generate token, and there is the personal access token. So this is actually what it's looking for when it's asking you for your passwords. Let me copy this here. We'll say copy. We'll go to the virtual machine. Now, what I'm going to do is I'm going to let this air out so that you can see. Let me come back up here. All right, so we'll do that. So we'll say Travis P. Bonfili. Now, if I try to put my password in and hit enter, this is where you get the message saying in August of 2021, the whole support for password authentication was removed, right? So it's now these personal access tokens. So from here, we'll rerun that. Let's clear the screen here, and we'll say Travis P. Bonfili. And this is where you're going to paste in your personal access token. You're not going to see it. It's not going to echo out to the screen here, but it's there. And yes, I've got to do the fetch first. So That was the push, and it failed because the updates were rejected. The remote contains work that you do not have locally. And this is usually caused by another repo pushing to the same reference. All right, so what I could do is I could do a git pull to pull down the most recent version, right? Or I could do what they call a git fetch from the origin, right? To pull the original down. So I'm just looking at the time right here because I want to make sure we get some other stuff in. So that is how you would push to your repo. That's how you generate the personal access token. One of the other best practices is what you want to do is you want to make sure that you can work in the main branch, right, called master, or you can check out another branch and work in that branch, right? And basically create like a development branch. And I want to cover something here real quickly that is in the reading for this week. They show you, and where's that? Not that image. They show you an image here, which there was a bunch of questions last semester on this image. So I want to bring it up so that I'm clear on what it's actually showing you here, right? So these two images are representing a timeline of things that are happening in terms of the check-ins, right, from a file view perspective, and then the version view. And so if we look at this right here, so version 1, you've got these 3 files. And this is the same time space over here, version 1. So here are these 3 files. Well, here we check in file A, A1, we check that in, and it becomes version 2. Now you'll notice that B did not get checked in here, and C did not get checked in here, right? So we can X those out. But for version 2 over here, we have a snapshot now of A1. So we're working on version A2, right? Because we checked it in, and we have a snapshot of A1. B1 and C1, these are just reference links to that version, right? So it's not a snapshot because we didn't check anything in. So then when we come to version 3, you can see we don't do anything here with A. So A is just a reference link because A never changed. And so this is what GitHub is doing behind the scenes. But we decide here we're going to check in B2. And so then we go from a reference link, and now it's referencing a snapshot of B2. And then we've got nothing here for C. So C is still just a reference link. So then for version 4, right, we check in A3. So now we have a snapshot. And then we check in B2 and we get a snapshot. And then we don't do anything with C ever here. So then again, it just points to a reference link for the different versions. So again, when there's no changes being made, right, these files that are in your repo, that if you are adding things and checking things in, this is what's actually happening kind of behind the scenes. Now, the good news is, the good news is that you guys will really only be working with one file. There'll be different versions of the file, obviously, because people will be making changes. But one of the first things that you would want to do once that file gets uploaded, or whoever puts it into the GitHub repo, creates the repo and makes it available to the rest of the team, is that you would go ahead and you can pull that down. Like you saw me pull it down, right? Then you could check it in and you can do your work on it. And again, you don't have to branch off. Sometimes the branching becomes a little bit confusing. And that's probably the most, actually, that's probably the most confusing part, are the branches, right? And so just to cover this before we take a break, if we come back over here, right, into the Git intro lab, and if I say Git status, you can see that we've got this dev ASC study team that's never checked in, and that's okay. If you say Git branch, that's going to show you the branches that have been created. So let's say for this dev.asc.txt file, right? I want to go ahead and branch off from the master branch, right? So if I was to say git checkout, and I'll go into the test branch. So you can see I says switch to branch test. So now this would be a branch off of the main branch where I could do some testing. But watch what happens here when I say ls-la, and then I do a more on the dev.asc.txt file. So what is different with this file? You'll notice it's not updated like the main branch one is. So what I could say is git merge, git merge master. And you can see here that what happens, right? This fast forward means that we're kind of like skipping ahead in time over all of the changes that have taken place in that dev.asc.txt file. When I merge it, right, to this branch, what do we get? Let's say ls-la. Now when I cat dev.asc out, aha. So I merged the changes that were on the main branch into the test branch, right? And so let's walk through an example of how this might work. So here I am in this, well, actually, let's do it. I'll do it in the temp directory. So here in the temp directory, if I see, and we'll actually use this directory for this anyway. So you can see here, this is a GitHub repo. So I go ahead and I pull down my dev.asc text file. And so I'm going to do just a bogus, oops, sorry, I wanted txt, so hold on. I'm going to do a bogus version of this file, right? And again, it contains this, right? So here we go. I've got this stuff in here. So now if I say git status, right, you can see it picked it up immediately. It's because we've initialized the git repo here. So it says, hey, you've got this file here. So what can I do? Well, I can add it, move it from the working area into the staging area. So now that it's in the staging area, here it's green because of the git add command, meaning it's now ready to be committed. And I'll just put in here, blah, blah, blah. That's my comment. All right, so we're going to do the git commit -m. And you can see we've got one file that had been changed. 5 lines have been inserted in that file. So if you pull down the file from a GitHub repo, and you've got it here in your GitHub repo directory, and again, I just created the file so we have something to work with. So what I could do now, and this is probably a best practice, is to go ahead and create a branch, and you can call it whatever you want. So I'll just say test. So now if I say git status, I'm sorry, if I say git branch, you'll see that we have 2 branches. Now, the test branch, how do I get into the test branch? Well, I just check it out. So I say git checkout test. Because again, remember, in the main branch, we have sort of the template file. Think of it as like, the original version of the file. And now I'm going to switch into the test branch. So when I type ls-la and then I see, oh, I have the dev.asc text file, I can still see it. And it has those lines in it. Now, when I'm making changes in the test branch, those changes are not being auto-magically replicated into the main branch. Because again, I'm branching off here because what do I want to do? I want to write some code, test some functionality. If it works, okay, great. So here's what I could do. Like on my first attempt here, let's say I go into the file, and remember, I'm in the test branch. And I decide, you know what, I'm just going to do a bunch of numbers now. So I'm going to add in some new Python code here, right? I'm going to save it. And let me go ahead and say git status. And you can see it picks it up. Hey, you've modified this file. So I'm going to say git add dev.asc. Now remember, I'm not in the main branch. I'm in the test branch still. If I say git branch, you can see that, right? It's got the little asterisk next to it, and it says test is green. So I've added it. I made my changes. Went ahead and added it to the staging area, and now I'm going to commit it to the GitHub repo index. So I would say git commit -m, and then just some comment stuff here, and hit enter. And so now when I say more on devasc.txt, I look at that, I'm like, okay, great. Well, then I realize, you know what? Yeah, I'm going to pull out these last 3 lines here, because that code's not working for me, and I need to add in something that says this is the end of the file. So we'll save that, right? So we save the file again. I'll do git add devasc, move it from the working area to the staging area. Then I'm going to commit these changes, git commit -m, put that in there. And if I cat it out, we can see the contents of the file, and it's been changed. So now I'm going to go back to the master branch, right? The main branch here. I'm sorry, I want to git checkout. So there we are. So now if I say git status, I can confirm that, hey, I'm on branch master, nothing to commit, working tree is clean. What does that devasc text file look like? Well, you can see that none of the changes are here. Because remember, we did all of the changes we did because we were testing in that test branch. Because I'm making changes, I'm saving the things that are working, I'm deleting the lines that aren't working. And I did all of that. And now I'm happy with what I did in the test branch. And I want to merge it into the main branch. So how do you do that? It's really simple. You say git merge test and hit enter. And you can see what it does is it merges the last committed version from the test branch into the file that is here in the master, the main branch. So now when I say more devasc, keep hitting lower. There we go. It's like the shift key was stuck there. So you can see I've merged those changes in. But what happens if I say git status? Nothing to commit. Everything is clean. So I merged it in. There it is. And so now, after I've done all my testing in my test branch, if I didn't want the test branch, I could delete the test branch once I'm done with it. With git branch -d for delete and test. And that branch is gone. So now when I say git branch, that's the only branch we have. So you can keep that branch and leave it there, or you can delete it if you're done with it. But the important thing is, I was doing all that work that I was doing. When I checked the test branch out, none of that work impacted the main branch copy and version of that file, right? And that's what we wanted to see was, okay, can I, maybe if I made a mistake in the testing area, that, you know, okay, great. You could just create another branch if you wanted to off of the main branch called test2. And then you could do test3 or test4. You know, you could have as many branches as you want. And that's the real power of Git. And then again, being able to push those files up to the repo. And you'll do that this week in the lab 3.3.11. You'll create your repo. You're going to push the file up there. You're going to get yourself all set up. And that is pretty much all we're going to cover for Git. Again, you're going to see a lot of this in the lab. What questions do you have over what we covered? And again, like I said, the lab is really good. It takes you cradle to grave on everything that you need to do to get stuff up to GitHub.
What was the command to add to the master? It was git, and then it's the branch name, and then was that it?
To merge?
To merge into the master, yes.
Yeah, so if you were to, so great question. So if I was to say git branch, you can see we have a single branch, right? And in this branch, we've got the devasc text file. So if I was to say git branch, and then I wanted to do some testing, right? So I'll call it testing. So now I've got this new branch called testing. So if I say git checkout testing, this moves me into that branch. You can see switch branch to testing. You can always check by saying git branch.
Okay.
And you can see here that it shows me right there that now I'm in the testing branch. Well, what's in the testing branch? So there's that devasc.txt file. Okay, great. Do I have to do anything right now? No, everything's been committed, right? Because it was already committed in the main branch. So when I when I create the testing branch, which just basically branches off from where main is currently at, and I decide, you know what, we got to do more testing here, Travis. This isn't working for me. We're having bugs, and so now we need a bunch of lines with Z's, right? So we're going to add this in, and again, this is I'm just I don't want to sit here and write a bunch of Python code because it'll take forever. So this is easy. So okay, great. We've done our testing and we are happy. That is doing exactly what we wanted to do. So what I would do, if you say get status now, you'll notice that GitHub says, wait a second, none of these changes that you've made have been committed to this branch yet. So we need to move it from the working area to the staging area with git add and the name of, oops, something's wrong with my shift key. So we add it. So when I say get status, you can see that it's green now. It's in the staging area, meaning, hey, it's ready for me to commit this file, -m. And you put, and the best practice is the first 50 characters here should be very descriptive. And then you can actually hit enter. And then everything else you put in for your comment should be like a super detailed description. And then when you're done, you get your closing quotes. And there we go. Right. So that was just a quick sidebar that the best practice is when you're putting these comments in here, these first 50 characters here on this line should be kind of like, change number, whatever, blah, blah, blah. And then you hit enter without closing the double quotes and you put in a very detailed comment. So we've made these changes. It's been committed to the GitHub index, right? And so now when I say cat dev ASC here, we should see all of the Z's. So your question is, we've done all this testing. Hey, this is working great. Now I want to get back into the main branch, right? Because I'm ready to incorporate and roll all of Christie's changes into our main branch of code. So I would say git branch to prove, okay, I'm in that main branch. When I look at the dev ASC file here, you don't see any of the Z's here, right? There are no Z's because all of those changes were in the testing branch. But we're satisfied that all that the new features and functionality that I added in the testing branch, we can now pull in to the main branch. And so to do that, you say git merge, and then the name of the branch from which you're pulling the latest committed version. So we say git merge, and then you can see here, we added 6 lines, right? 6 insertions took place. So there's the file. So now when I say more dev ASC, Git has tracked those changes for me in the testing branch. And then, like I said, let's say, okay, hey, I'm done testing. And so I don't need that branch anymore. So it's just git branch -d testing. And we don't need the testing branch because we did the testing. It worked, and I've merged those changes in. So let's clean it up. Or if you wanted to leave it behind for historical purposes, because maybe you want to go back into that branch and look at what you did or check something out. And if I say git log, you can see, right, all of the changes that have been taking place here. And you see that comment that I made, right? So that's where the comment would show up, by the way, when you say git log, because git log is tracking all of these things that you've been doing. And you typically use the first 6 characters out of the commit hash, right? There's a 40 character SHA-1 hash. And this is how GitHub is actually tracking. If I go into that Git directory, and I think it's an objects directory, I thought it was in here. And maybe it's not, but it should have been. So this is where it's tracking all of those hashes that are tracking all of the versions that you are committing. Does that answer your question? Does that help?
Yeah, I got it. Thank you.
Okay. Yeah, no worries. All right. What other? And I just received an email saying that a personal access token has been generated on my GitHub account. Thank you. Okay. What other questions?
Hey, Travis, this is Dwayne. I have a question.
Yep.
So I'm kind of following along and I'm in the lab itself. and I just got to that point where I was doing the git diff, and I put the 6 characters from the commit lines. And right now it says I'm on my way to passing the Cisco dev ask exam. That's in white. The next line, I am beginning to understand Git, is still in red. Is that supposed to be red, or should that be white?
Oh man, I'd have to actually go back and take a look. I don't remember if it's supposed to be red or white. Have you committed the change?
I thought I did. Let me see. Yeah, in the previous line, I did the commit -m, add additional line to file. But I had trouble at first figuring out it was just the first 6 characters. I was trying the whole string. And then
And the whole string should work. The whole string does work, but you really only need the first 6 characters.
Okay. So I ended up going back after that, did the git div and the first 6 for each commit. But yeah, I'm not sure. I'm on the lab itself. That's what's a little different. It has a plus I am beginning and it's highlighted in yellow. Mine has a minus I am beginning. So I'm wondering if maybe I need to commit that second part again.
Yeah, I would just go back and double check to make sure that you didn't miss a step.
Okay.
Yeah, I would just double check to make sure that you didn't miss a step. And so the git diff, so let's do this. If I say git diff and I do this 3, 4, 5, 6 and copy and paste, and then we'll grab this one here, 5, 6, say copy and paste. And again, this is going to be, this will be different. So are you seeing, because I'm
like that.
Okay. Yeah. So what you're seeing here is, and if we were to break this down, right? So this is the first version. So when you see the AB, this is the original version, right? Or the first one that you're diffing or comparing to the second one.
Oh, okay.
So then what you see here, and let me give you a good example, because this is the original file, right?
Okay.
That's the original file. The first one that gets listed is the original file. You'll see the minuses there. The second file, right, is the file that you are comparing it to. The file being compared, and give me 1 second here. And then it tells you, obviously, the name of the modified file is dev.asc. So when you see these lines right here, this is called hunk headers, is what these are, right? What you see right here. And this is indicating the changes that were made to the file. The changes start at that line number, and then they end at that line number. And let me make sure I get this correct here. And then it shows, in this case, the header indicates that the changes start at line 1 of the original file. Oh yeah, so the changes start at line 4 of the original file and go to 12, and here it starts, and then from the comparison file, it's from lines 4 to 6. And 3 lines were removed from the original file, and 4 lines were removed from, so yeah, so this is showing that 4 lines were removed from the original file, and 4 lines were added to the modified file, and the actual changes made were here from the original file to the modified file. So if you're seeing this, that was when, that's the difference between the original file and the modified file, was that these were not there.
I got you.
Is that, and then when we merged it, then they are, but we're comparing here, we're comparing the original file or the latest commit with the previous version of that file before we had all the Z's in it.
Okay.
Okay.
I just went into I just did the cat command for the file, and both lines are there.
Okay.
So yeah, I see. Yeah, how it's comparing them now.
Okay. So yeah, and this is probably, and for those of you that are taking the certification exam, I could swear that there was they had a question on there that showed the get diff output similar, not with as much going on here, but similar to this. And I can't remember exactly what they were asking, but there's definitely a question on the certification exam with the get diff output. I wish I could remember what it was. I can't, but I'll be retaking it. The good news is for you guys, I'll actually be retaking. I do this at the end of at the end of your semester, is I'll take the certification exam. That way I can provide you with very focused guidance, I'll put it that way, on what you should be preparing to see. And we'll just leave it at that so that we don't break any NDA or anything like that. All right. What are the questions? Anybody else have any questions? And again, the lab, when you work through the lab, you're going to see all of these things. You're going to see everything that you just saw me do. All right. If there's no other questions, we're going to go for do a quick 10-minute bio snack break. So we'll come back at 8:27, and then we're going to talk about the Python lab. So let me pause our recording here. Everybody still with me? I hope. All right. So we are back from break, and now we're going to shift gears here into lab 346, I believe it is, to cover some of the topics that they talk about in terms of, it's a review of Python classes, and then they get into functions, and then they start to talk about methods, right? So first things first. So a function, and in the functions video I did up, I give you a bunch of different examples. Let me clear the screen here. Let's go into Python 3. There we go. Okay. So a function, right, is a block of code that is going to run over and over and over again, or you could call it over and over and over again. And maybe it's something that you don't want to have to continually type in your program. For example, maybe you have a function that is going to welcome somebody or print some message up that you would have to type it out a whole bunch of times, but you don't want to. So what we can do is we can actually go ahead and create our own function. And we do that with the def statement, which stands for define. And I'm going to say def message, and I'll do open parent, close parents, because while you can pass arguments in, you don't have to pass any arguments in if you don't want to. Now, when you're in the interactive interpreter here for Python, remember, you're going to go 4 spaces in, right? Those 3 dots are kind of urging you to go 4 spaces in. And so here's where you could put what we refer to as a doc string. And I've mentioned this before. We can do strings with single quotes. We can do strings with double quotes. But if you do triple single quotes, you're actually creating a doc string. And this would be something that the user would see if they were to run the help command, the help function on your code. And so I'll give an example here. I'll say, here is my help message that describes my code. And again, we put it inside the triple quotes. Now, this could also be multi-line if you wanted to be multi-line. So you could have it look like that. You could have it look like this. Oh, sorry, hit enter. I was going to try to space it out. So, but you could have it as multi-line, where you put the 3 quotes, and then you hit enter, and then you put in the rest of your code, the rest of your message, and then you close it out with the 3 quotes. So we'll do this. So here's what this function is going to do. It's going to print, welcome to my program, right? And then you just hit enter twice. So now I've defined this function with the name message. So when I say dir to see what is in my current namespace, you can see in the current namespace, it sees my function message. So what if I say help? Because I'm not sure what that function does. And here you go. And you can see, like, it's like a little help page. And so here is where your doc string would show up, is if somebody were to run help on your function to see what it does, right? So pretty simple. So how do we call the function? Well, to call the function, you just say message open parent, close parent, right? Because that's how we use functions. And you've seen functions before. Print is a function. And I can run print with nothing in between the parentheses, right? I just say print open parent, close parent. It just prints a blank line. Print is a function. Dir is a function, right? We saw string, and we want to give an, it shows you that right there to show you that, hey, that's a string. If I say int, right? These are all functions. But sometimes you want to create your own functions that do something that the built-in provided functions don't necessarily do. So again, they had this thing where they'll have you put a city name in, right? So let's do, if we did another function that took an argument, right? Like we want to pass an argument into the function. And something that's popular for examples, which is pretty cool, is you can just do like a calculator type function. So I can say add. And so this is going to take 2 arguments. And what are we going to do with these 2 arguments? Well, we're going to add them together. Now, I'm going to leave, this is going to be a mistake here intentionally. So, we'll say, yeah, we'll just, or here's what I'll do. So we'll do sum. So we'll create a variable, because this will be a good example. We'll say, create a variable, we'll say x plus y, right? All right, now there is something that's not right here with this program. So if I say add, and I pass in 3, 3, well, we should see 6, right? So, but what happens when I type sum? And you can see sum is actually a built-in function, but we're not getting a value. And that's because the values that you define, the variables we define inside of a function, those are what's considered local scope, meaning unless we return that value from the function back to the main program, the calling program, right, or the calling namespace, which is this main namespace here, we're not going to get that value back, right? So if I was to change this code and say x comma y, right, and we'll say, and I'll use num1, use something different. So, or just num. So num is going to get the value of x plus y, and I'm going to return num, right? So I'm actually going to return to the caller, whoever called the function, I'm going to return the value of the variable num, which, depending on what we pass in to this function, could be whatever we want. So we'll say add, and I'll say 10, 20. I hit enter, and you can see it returned 30, right? So that's how you can use arguments that you pass in to the function. And actually, I should probably refer to this one here, where we assign the result of whatever that mathematical operation is to that variable name, and then we return that variable name. But here's the thing. If I type in num, it says num is not defined. And the reason that num is not defined, remember, this is inside of this function we created, so it's only relevant inside that function. And again, this is why we have to return the value from that variable back to the main program into the global namespace, okay? So definitely remember that and keep that in mind when you're working with functions. So trying to think of different examples they showed. Well, they showed passing, like calling it with a city name, but we'll stick with a calculator. Now, you'll notice that sometimes you might end up with errors, right? So what if I said subtract? And we're going to pass in, we're going to take in two arguments here, right? So we're going to say define subtract, and we're going to say, and I can't remember what it is, so let's call it num again. And we'll say is x minus y. And let's do return num. And then we could do another function called division, or we'll say divide, called divide. And we'll say x comma y. And this is going to show us what happens when you have an error, because the addition one, it's kind of tough to get an error with that, right? Because it's going to add X and Y. But when you do division, you can't divide by 0. And I can show you that from right here. If I said 9 divided by 3, well, actually, I'm sorry, 9, and you do the 2 forward slashes to get the integer division instead of the floating point division. So if you say 9 divided by 3, you get 3. If I say 9 divided by 0, we get a 0 division error, right? And so this is where, with some functions, right, you could pass something in. If I say divide, whoops, and we say 9, comma 0, we end up with a 0 division error. So keep in mind that not all of the mathematical stuff is going to work like you think. And this is where you could check to see if the value that's coming in is less than, or you should say is equal to 0, right? And so you could do an easy if statement for that. So I could say if divide, and we say X comma Y, and 1, 2, 3, 4. I can check right away. If Y is equal to 0, and then I can simply, well, actually, don't want to, yeah, I can just return out. So as soon as you say return in the function, that's it, the function, it's over with, right? Or I could do something maybe a little more helpful. If that's the case, I could say print, oh, I'm sorry, I could say print, you cannot divide by 0. And then, so if that's true, then it's going to print out you cannot divide by 0. And then we're still going to get the 0 division error. And we don't talk about there's a way you can do that's called try. And you could try something, and if it doesn't work, you can catch the error. But we'll just leave it as it is here. So if Y is equal to 0, print you cannot divide by 0. And then again, we could even kick out of the program here by saying return. And if not, we could do something like this, where we still say, num gets the value of X divided by Y, and then return num, right? So let's see what happens if I call divide and I say 9 comma 3. What does it do? It gives us 3. But what if I say 9 divided by 0? You cannot divide by 0. And again, as soon as you say return, that is it. The function, it kicks you out of the function. You're done. And you'll notice that it didn't do all of this down here because we caught the little mistake, right? That, oh, that's right. I can't divide by 0. So I've got to come up and do something else. And so that is a function, right? So the more complicated piece is going to be the classes and the methods, right? And we talked about classes a little bit last week. And let me clear the screen here. So we could do class router. And let's do, so we can do class router. And then again, you could do a doc string here. And I want you to think of a class as nothing more than like a factory that is producing objects of that class type. And the same thing is true. We've already seen a bunch of different classes of objects. We've seen integers, strings, lists, dictionaries, tuples, the whole 9 yards, right? So, but what if there's we want to create objects that there is no class for? So there is no like router class, right? Oh, is there a question? Okay. Yeah, so there is no router class, so we have to create that router class. So here's how you would create it. And we're going to do, and this is referred to as a constructor. And I'm going to explain this line here in just a second. So we're going to say self, I'll say serial number, because routers have serial numbers. I'll say host name. And I'll say IP address. All right, so we've got that in there. And then let's go 1, 2, 3, 4, 1, 2, 3, 4. Self dot serial number gets serial number. And so I'm creating a class from which we can create a whole bunch of different objects. Self dot, what's that, host name gets host name, 1, 2, 3, 4, and then self dot IP address gets IP address. Okay, so we're not going to do a method in here. I think that is going to be good enough. So this is our class. So what are these lines doing? Well, the very first one should be pretty obvious. This is defining the class name. And the class name is just simply router. And so when we go to create objects of this class type, we're going to be referring to it with router with a capital R. And the reason that you use the capital letter here is so that it doesn't get confused with function names. So class name should always start with a capital letter. Okay. All right. So now we've got what appears to be a function, right? Because this kind of looks, you know, we've got the def statement here. And while it takes on the form of a function, when it's in a class, it's a method. Okay. And so that's the difference between functions and methods. Functions you can run by themselves. Methods are inextricably linked to the class in which they're defined. And let me give you an example of that with a list. So if I create a list called my list, and let's just make it empty, right? When I want to append something to this list, I use the append method. Now, I can't run append, like if I type append and do this, like let's append the integer 1, I can't do that, right? Because Python's like, I have no clue what append is supposed to be related to here. Like, what are you appending to? So this is the method, right? And the method is inextricably linked. It's tied to the class, the object of whatever class it came from. So append is a method from the list class. And if I was to say my list dot and hit tab twice, you can see all of these different methods: append, clear, copy, index, extend. Again, those are defined inside the list class, just like we would define a method inside of the router class. And so we'll put something, and I'll throw in one of the methods here in a second. But hopefully that's the major difference between functions, which can be run on their own. Like you just saw me run the addition, the division. I can run those by themselves. They're functions. Methods have to be run with as part of the class, right? When you're using objects from that class. So we've got this class router, and you can see here we're defining this method right here. And this is called the constructor. And I want you to think of init as, like, remember I said, if the class is a factory, the init constructor is like the green button on the wall that you press to get the factory churning stuff out, right? So when I call, or when I instantiate an object, create an object from the router class, this is the very first method that gets called right here. And it's going to make sure that I've got the serial number, the host name, and the IP address as part of my object creation. And so self, and this is a convention. You could put in here blah, blah, blah instead of self. But this is a best practice convention, and this is what you should be using is that word self. And what it represents is the name of the object that you're creating. So to give you an example, if I was going to instantiate an object of class router, I could say, okay, so router 1 is going to be from the router class. It's going to have a serial number of 8675309. It's going to have a host name of router 001 and IP address of 192.168.1.254, right? Maybe that's the management address. So this Right there, I just instantiated, I created an object from class router. And this is how you create the object. And that right there, RTR1, when I go to create this object, that value, RTR1, is the self argument to the call of this method. And so it's RTR1 dot serial number, RTR1. So it's basically making it generic so that I can create router 2, router 3, router 4. It doesn't matter what my variable name for the object is out here. It is represented as self when the values are being applied to the object. Now, let's say, I create this object and my boss is like, well, that's great. You've got the serial number in there. You got the host name. You got the IP address, but we forgot to add in location, right? So you could actually add in a location, or actually add in an attribute, right? And these are referred to as attributes, the serial number, the host name, the IP address. You could add something like that in after the fact if you wanted to, right? But for right now, this is my object. So how do I get those values out of that object? So if I say RTR1 and hit enter, you can see right here, right? Oh, okay, so it's an object, and all this at, that's the hexadecimal representation of the location in memory where router 1, the object, is sitting, where it's defined, right? So this is in memory where it's tracking router 1, and you can see it's an object from the router class, just like we saw when we would do the type. In fact, if I said type RTR1, there you go. It's from class router. So we can see it's an object from the router class. And so now that I've got this created, right, if I want to see the values, I could say RTR1 dot serial number. What are we going to get? Sorry. And I'm going to do RTR1 typos. So if I want to see the value of an attribute of my object, I would see it right there, right? So there it is right there. Simple as that. So what about the host name? What's the host name of router 1? RTR host name. So, and if you were to create objects, and then let's say you wanted to, you prompt the user, enter the name of the router for which you want to know the serial number, right? So you could do something like this, and we'll just say, user input is enter the what did I say? The IP. We'll just do host name. Enter the host name of the router, of the router you want to see info on. And we'll leave it like that. So enter the router of the host name you want to see info. So I say RTR1, right? And so now that user input, remember, user input captures that value, it's RTR1, you could then use that and say, print the serial number of RTR1 is, whoops, single quote there. And I could say, where's that? User input dot serial number, right? Because again, remember, user input represents RTR1. That's what the user just typed in. And I want to see the serial number. So I hit enter. And is it going to force me to do? Let me see here. Oh, yeah, we'll get it that way. And it's not going to show me the user input dot serial number, even though it tracked it. It should have given me that. No attribute serial number string. Oh, because it's looking at it as the string object, but I should have gotten that. Yeah, so you could put in the actual name of the router dot serial number, and I'm drawing a blank here real quickly on what went wrong with my variable name. It's because it's a string. because it's not referencing the object. So we're going to have to let that go for right now. I need to think about that. So, but you can see here, you could do a print statement and say the serial number of router 1 is, and then you can get the serial number out of it, right? If you wanted to see something else, like the IP address, even though it says the serial number, we'll just go with it. And so that's how you can manipulate those things. All right, so that is the class. Let's take a look at adding a method to that class that actually does something. All right, so and we're just going to have it print out the values or something like that. So I can say, let's clear the screen here. Say class router, and we've got our init constructor. And this is going to take in self, and self is always the first argument there for the init constructor. And we're just going to make this one really short. So we're just going to use, we're going to use serial number and host name, and just leave it at that. All right. And I forgot my colon at the end of the line there. And so for here, it's just self dot serial number, and then 1, 2, 3, 4 self dot what do I do? Host name. Okay, so that is my method right there, the constructor method that I'm using. But I can have other methods, and I can define those methods down here. And I could say this one's going to be called router info. That seems like a good one. So we'll say router info. And again, there's that self keyword. We'll use that. And what is this going to do? It's just going to print out the info for the router. So the serial number is, and put a comma in there, serial number. And then we'll do, oh, you know what? I got more than one thing here. So hold on 1 second. Let's do concatenate this together here. So we'll say the serial number is serial number, and the host name is, and then we'll concatenate it, and I'll say, oh, you know what? I need to do self.hostname. There we go. All right. So I'm going to do self.serial number and self.hostname. And let's run this down to the end here. All right. So now I've got this method defined in here called router info, right? All right. So that should be enough. So now let's create router 99. And router 99 is going to have a serial number, and it's going to have a host name. And we'll call it router 99. And so those two arguments that I pass in are going to create this object. So if I say RTR99 dot serial number, we get the value. If I say RTR99 dot host name, we're going to get the host name. But here's the interesting thing. If I say RTR99 and take a look there, I hit the tab key twice, and Python knows, hey, like these are attributes, right? Serial number is an attribute, host name is an attribute. But when I see that little open parent there, router info is actually a method. Again, this is how easy it is to define the methods. Now, again, ours is not doing anything too important. So router info, open parent, close parent, and there you go. So you could create a bunch of objects, and then in order to get all of the information from a single object, you could have a method called device info, router info, switch info, right? And it would, you put a print statement in there that would print out all of the different information for that device. And that is how you would create a class. That's how you would add a method to it. And again, I'm doing it all here in the interactive interpreter. which can sometimes turn into a lot of typing, right? So you can put this in VS Code as well. Everything you saw me do here, you could drop into VS Code and then put in the statements at the end, like, print router 99.router info or print router 99.hostname. And so that's how you see the attributes, and that's how you can see the methods that are in there. So what questions do you guys have on classes, methods, or functions? Classes, methods, or functions? Any questions? And again, you're going to see this, you're going to get to walk through this, and it's different information that you're going to be typing in and stuff like that. But this is all part of Lab 346 on Python classes. No questions. All right. So if there's no questions, I will go ahead and let me stop the recording here.